Yeah, I think Namaskar, Shubho Sandhya Sabaike. Good evening, everyone, and a warm welcome to Kolkata R user Group's third virtual meetup. I am Somrit, lead organizer of Kolkata R user Group, and by profession, I'm a data scientist and an R enthusiast. As promised, we are back again with another exciting session with another guest speaker. So, before getting started, I would like to take a moment to highlight our recent group's activities. We had an exciting session on everything with Quarto last month and another session on innovative approach to teaching data analytics to business students with R. If you missed it out, do check it out our YouTube channel. The recordings are available there, and do not forget to subscribe the channel and do follow us on LinkedIn as well. So thank you. And our group is proud to be a diverse and inclusive community, welcoming individuals from all backgrounds and industries. So whether you are a student, researcher, or professional, or simple curious about statistics, data science, and art, we invite you to join our sessions, ask questions, and learn from each other. So without further ado, let's welcome today's distinguished speaker, Susmita Chatterjee, who will enlighten us on the topic structural equation modeling with R. So Susmita Chatterjee is an assistant professor in the economics department at Maharaja Monindra Chandra College, University of Calcutta. She holds a PhD and MPhil from University of Calcutta and has completed postdoctoral research at IIMC. Her research expertise lies in applied econometrics, industrial organization, gender studies, and entrepreneurship. She has published numerous articles in top tier journals and authored 3 books, as well as book chapters in national and international publications. Additionally, she serves as a reviewer for Sage journals and Oxford books and supervises PhD students in the departments of commerce and economics at the University of Calcutta. So I welcome again Sushmita Chatterjee. Over to you, madam. Ma'am, are you are mute actually? Uh,
Am I
Ma'am, yeah.
audible? Am I audible now?
Yes, yes, you're audible. Yeah.
Yes. So, শুভ সন্ধ্যা সবাইকে. So we are starting with the session, and today's discussion will be on structural equation modeling.
Ma'am, you can start sharing your screen and go ahead. Yeah.
I think my screen is shared now.
Yes, yes, it is up. Yeah.
So I'm starting with the discussion on structural equation modeling. Before going to particular the complex model, I would like to analyze some simple factors associated with structural equation modeling. So, in brief, I will discuss exploratory factor analysis, the variance covariance matrix factor analysis model, model implied covariance matrix, and the simple path diagram. One factor confirmatory factor analysis, and some model fit statistics. And everything will be done with the help of R software. So this is the overview where the structural equation modeling, when we are going into the modeling this multivariate technique, we have to know about the exploratory factor analysis and confirmatory factor analysis. In case of exploratory factor analysis, we are trying to reduce the dimensions, the common dimensions we are trying to get out of several variables. Now, I would like to introduce one particular example so that we can clearly discuss the issue of exploratory factor analysis. In this particular research, in this example, we have several items or several variables. These questions are the variables. And the research issue is measuring the technology readiness index. In that case, we have 60 item scale. Now, some optimism measurements are there. Some innovativeness measurements are there. And the scaling is done accordingly from 1 to 5, strongly disagree to strongly agree. This is a kind of Likert scaling. In our studio, we have to first import the data. So the command for importing the data in our studio is this. So from read Excel, we can read the Excel file. Then we have to do the factor analysis. In this particular research, we are trying to get two factors. For these two factors, we are giving the command or the syntax that first this ISI 23rd is the name of the data, the Excel file, where we have data for these variables, 8 variables. And from those 8 variables, we are trying to extract 2 factors. So the command is like this. The name of the data dot FA for factor analysis. Then factor null is the function. Then we have to give the name of the data and we have to mention how many factors we are trying to derive from those variables or those items. Then we are trying to get the uniqueness of all these variables. Then we put the command first the data name dot FA dollar then uniqueness of all these items. Thereafter, we are trying to get the factors and the factor loadings. And in one sentence, what is factor loading? Factor loading is nothing but the relationship between the item or the variable and the underlying factor or the dimension. Here we can put the syntax, first the data name dot FA, that is for factor analysis, then the $sign and the loadings. So this will be the command for the factor analysis to get the loadings. And here we can see the loadings. For factor 1, this optimism variables, optimism 1, 2, 3, and 4, having loadings 0.726, 0.681, 0.432, 0.449. And for factor 2, 4 variables are there, innovativeness variables, and they are having the loadings 0.5 above 0.5. So in this particular analysis, we have these 2 factors and we are getting these factors from, or the loadings of the factors from the command, the first the data name dot FA dollar loadings. So this is the procedure to get the loadings of the factor analysis. The uniqueness, sometimes referred to as noise, corresponds to the proportion of variability which cannot be explained by a linear combination of the factors. So we have to check the loadings as well. The high uniqueness for a variable indicates that the factors do not account well for its variance. So we need some moderate uniqueness. Thereafter, we will check the rotation of the factors. For rotation of the factors, we have to put the particular syntax where we have to give the type of rotation so that we can derive a very good positioning of the factors. And the command is text name of the data dot fa dot varimax. This varimax rotation will give you highest or maximum variation in the factors so that you can distinguish two different factors. Now, so this is the plot for the varimax rotation. Here you can see in factor 1, optimism variables are there, and in factor 2, innovativeness variables are there. So by varimax rotation, we can get a particular axis for both the factors with the clustering of the variables. Clustering of the variables. So again, I would like to give the syntax text ISI 23rd, the name of my data file, the Excel file, .fa.varimax, $loadings, and then the color of the columns I have taken blue, and the origin is 0, 0. The origin is 0, 0. Now for first install the package foreign and package Lavan. Now I will not give you rigorous mathematical explanation, but I am just give you the model description where we are trying to estimate y, just like regression equation. Here the variables are latent variables. So if there are 3 items, y1, y2, y3 like that, then this is the intercept, and then this lambda 1 is the loading between factor eta 1 and the item or the variable y1 with the measurement error epsilon 1. So this is the back of the stage model specification. Now, this is the model implied covariance matrix. These are the loadings and these are the error terms. Now, for the path diagram, we have some particular legend. For the latent variables, we take the either ellipse or the circle. For observed indicators, we take rectangle. For intercept, we take triangle. For paths, we take this particular arrow, and for variances and covariance, double-headed arrows. So this type of model we measure in case of analysis. Now, I would go to one factor CAP. I would go to one factor CAP. Now, in one factor CFA, we have to estimate the parameters. Now say this is a particular one factor confirmatory factor analysis. And in short, I would like to describe what is confirmatory factor analysis, where there is a particular premise behind the factor analytic model. A priori theory is there. So I know these four variables are loading to this factor optimism. So I have a prior theory. If the researcher has the theory in his or her research work and try to establish that theory, then the researcher will go for confirmatory factor analysis. Now, in confirmatory factor analysis, this is the R code. Say, we have to put the syntax round cov for covariance, then put the name of the data, comma 1:4, 4 variables are there. So we have to take this, then the relationship of the factors. So you will get the covariance structure. If you take 3, then it will be 3. So this is the covariance. To get the covariance structure between different variables, this will be the code. And again, the total number of parameters will be calculated by P multiplied by P plus 1/2. P is nothing but the parameters you are having. So again, this is the structure where lambdas are loadings and theta 1, this theta matrix is the measurement matrix. Now degrees of freedom will be calculated by number of known values and number of free parameters. So this is a type of model we are going to estimate. And by the marker method, if we go by marker method, then the first loading of the each factor will be equal to 1. And in variance standardization method, this is the process where all factor loadings are given. Now, the Lavan syntax, these are the Lavan syntax. Tilde for predict regression equals to tilde indicator factor analysis, double tilde for covariance, tilde 1 intercept, 1 star fixes the parameter, NA star frees the parameters, A star labels the parameter. These are the Lavan syntax. Now, this is the syntax for the model with 3 items and 1 factor. So, I have defined the model as M1A, the first model. Then this is the sign less than and the hyphen. Then we are starting the model specification. So OPT is the latent factor, unobserved factor, and this will be coming from 3 other items or variables: OPT1, OPT2, and OPT3. So this is the Lavan syntax. So 1 factor, 3 items, this particular model of CFA can be written as this. And then we will get the summary of this one factor, three items model. So first we have to define the model. Then we have to do the CFA with this command, and thereafter we will get the summary. So first defining the model with the factor and the variables. Thereafter we have to specify the CFA model, and this CFA model will be based on this particular factor analytic model. And this will be the result of this particular model. Then we can go for some other specifications where we can just standardize the model with fixing some variable, or we can do this covariance as well. And this is the result where the estimates are given for the latent variable, where OPT1, estimate of the OPT1, that is influence of OPT1 on optimism particular factor is 0.917 with p-value 0.000. So this is significant enough, and all other two variables are also significant enough. Now in model fit statistics, we will check the model chi-square and approximate fit indices. So for hypothesis testing, we accept the hypothesis, that is the estimated model and the original model will be the same. So there are several fit indices: root mean square, error of approximation, then model chi-square, Taka-Lewis index. These are all confirmatory factor index. We have to check all these indices to establish the model. The model summary will give all these values. The model summary will give all these values. Particularly, we will look into this comparative fit index. The comparative fit index in this particular example is 0.871, but if it is going to 1, then that will be better. So if it is approaching to 1, then the model will be a good fit. That is, all the variables are explaining the latent one. And for Taka-Lewis index, the explanation is the same. For root mean square error of approximation, the thumb rule is it should be less than 0.05. But according to your data, you may not get the proper result. That will vary according to the data, according to the research group. Now we will do the two-factor confirmatory factor analysis in R programming. This is the path diagram. So we have now two factors with observed indicators. The first factor is having 1, 2, 3, 4, 5 indicators. Second factor may have 2 indicators as well. Now, for correlated two-factor solution, the R syntax will be this. So we are again having one particular model and noted as M4B. And that model is specified as this. Here we are taking two factor. One is the optimism factor having 4 variables. The second is innovativeness factor having 4 indicator variables. Then two factor items we have this particular syntax for R. For two factors items, the two factor items B is the name given to the particular model. Then we will do the CFA with CFA command or the syntax, then specify the model, then after comma specify the data, and then std.1b true is giving you the standardized result. Standardized result. And the summary of this model, the syntax is summary, two factor 8 items model, fit measures. We need the fit measures, so we'll write the syntax fit dot measures equals to true, comma, we need the standardized results, so we will put standardized equals to true. Now for uncorrelated factors, we will put equation like this, where F1 and F2 uncorrelated. So put the syntax F1 double tilde 0 star F2. That syntax will specify no correlation between two factors. No correlation between two factors. Now again, summary we will get, and try fit. Try.fit is the name given to the fit model. We will do the CFA. Try.model will be the name of the model, and again we have to specify the data. We have to specify the data, and we will get the estimates like this. Now we will again install the package same plot to get the covariance structure between factors. The syntax is install.packages, then the same plot package will be installed in R. And after installing the package, we will put the syntax same plot, same paths, try.fit. This is the fit model, the name of the fitted model, and std for standardized. Std for standardized, and we will get the plot like this. Plot like this between two factors, optimism and innovativeness, with four variables. Now for fit measures, we will write the syntax fit measures. We will write the syntax fit measures, then put the name of the fitted model. Here my name is try.fit. Then C is the bind command, and then put all the fit measures name within the single inverted comma. CFI is the comparative fit index, root mean, square or error of approximation, then the upper limit of confidence, and BIC, the Bayesian information criteria. After giving this syntax, the result will be given. CFI 0.956, RMCA say 0.053 for this particular example, and the Bayesian information criteria. Now, as after the confirmatory factor analysis, we will go into the introduction to structural equation model, where we are taking into account the path analysis, confirmatory analysis, dimension reduction, that is the factor analytic part, and the path analysis, which is the regression part. So structural equation modeling will find two things. One is the data reduction through factor analysis and also the regression analysis showing the relationship, the causal relationship between latent variables. Now, structural equation modeling is a particular statistical technique used to analyze the relationships between observed and latent variables within a complex system. If we want to test the causal relationship among variables by combining factor analysis and multiple regression in a single model, then we will use structural equation modeling. The structural equation modeling framework can examine both the measurement model, that is the relationships between the observed variables, and the latent variables, that is the factors, and the structural model relationship between latent variables simultaneously. So same is particularly useful in social science discipline, in psychology, in marketing, in finance, in different fields where we try to understand, we try to gauge the complex relationship between variables. The structural equation modeling also involves constructing a path diagram, very clear regression relationship for estimating the parameters and evaluating the model fit. So when we have some complex theoretical structure, we can do the structural equation modeling. And in structural equation modeling, in measurement model, we have the observed factor in left hand side and the latent factor in the right hand side. Now, again, we will take another example to see this structure. In this particular example, we have the adoption intention of a particular group of people adopting the entrepreneurship. And for adopting entrepreneurship, some facilities, the marketing facilities and some material facilities are given. In this particular data, we have three variables for adoption intention, three variables for marketing, three variables for material availability. And in R, we can do this by putting the covariance, the command covariance of the particular data. This is the particular data named as BM1. This is a particular simple Excel data. As we have imported the Excel data by read Excel command, here also we will just get the data through read Excel command and just write covariance. So you will get the covariance structure of this particular data set. Cov command in R allows us to obtain the sample variance covariance matrix. The cov command in R allows us to obtain the sample variance and covariance matrix. Now, R codes, we are known with the R codes. Now, this is the R codes for this particular example, where we are trying to gauge the adoption of entrepreneurship by entrepreneurs through the variables marketing availability, that is marketing availability 1, 2, 3, and the material availability by three variables 1, 2, and 3. This MAA variable is marketing availability variable. MEA variable is the material availability variable, and adoption ADO is another latent variable comprising of two other indicator variables, ADO1 and ADO2. So the first measurement model in which we are trying to get the relationship between indicator variables and the latent. This MAA, marketing availability, is one latent variable which is comprising of these three indicator or observed variables. So in measurement, we are having three measurement models, and then we will do the regression. That is the path model. So ADO now related to latent variables. So in R, we are doing this by simple syntax. For measurement model, the syntax is put the latent variable name equals to tilde, then the indicator variables. For all the latent factors, do the same thing. And then for the path analysis, where the structural model is coming up, here we are just combining all the latent variables. ADO is one latent variable which is coming from or influenced by the marketing availability and the material availability. Then we will try to fit the model. We have named that fit 10. In our syntax, put the particular model name and then do the same. Same is the function, SEM. Then give the model name in your first model. Here, as we have taken M10 as the first model name, so do the structural equation modeling with M10 and data will be business data, the BM data, which we have taken for this particular analysis. And for R, again, the command for the summary statistics, fit 10. Fit 10 is the name of the model where you have done the structural equation modeling, and then you have to get the standardized score. So the command is standardized equals to true, and you want to get the fit measures. So comma fit measures equals to true will be your R command, and you will get the results. The comparative fit index value, Akaike Bayesian, and the adjusted Bayesian score, root mean square of error of approximation. So this is the simple R codes to get this complicated model done. And I will give this simple rules of thumb. For sample size, there should be a ratio of sample size to the number of free parameters. So you need 20 sample size for one free parameter. Now again, I will go on with some simple R libraries. You need to do structural equation modeling, library Lavan, library plot, library DPLYR, library TIDYR. This DPLYR library is very useful for make your data more simple. Then TIDR, library KNITR. These are all useful libraries you need to perform your structural equation modeling. Library MV normal test. This is multivariate normal test. Library multivariate normal test. And if you don't have the package, then just install the package MV normal test. In same analysis starts with an assessment about distribution of measured variables. Especially we need to assess the assumption of multivariate normality. We use MV normal test package for univariate Shapiro-Wilk W, and for multivariate normality, we need this Madhya's multivariate skewness and kurtosis test. Now again, I am giving a simple example. This is a consumer perception model. In this particular research, the consumer's perception is measured through the health score scale. In health sector, we can get the perception of the consumer about the hospital. It may be private, may be public. So efficiency and loyalty described by two latent variables EFI and L can be affected by hospital staff's attitude, then non-hospital staff attitudes, and the equipments, technology available to the hospital. In this case, we have the hospital personnel, non-hospital personnel, and FET, that is the equipment, availability of the equipment, all these having indicator variables. HP1 and HP2 indicators for hospital personnel's attitude, NHP1, NHP2 for non-hospital persons' attitude, FET defined by FET1 and FET2. The loyalty is having three indicator observed variables, and the loyalty is depending upon HP, NHP, and FET. Now we can fit the model by using the syntax fit.mod. Then again the function, we have to write SEM. Then we have to write the name of the model we have taken at first to describe the measurement model as well as the structural model. First three lines are for measurement model, and last two lines, the fourth and fifth lines, are for the structural model. The data we have to call equals to the name of the data, then again standardized values are called, then the estimator procedure we have to specify the MLM process, maximum likelihood process. Thereafter, the fit measures we need, so we have to put the syntax fit measures, fit.mod, chi-square scaled, degrees of freedom scaled, and p-value scaled. So these are the syntax we have to use. The Lavan same syntax is very straightforward. We define our model using Lavan model syntax, then specify technical details for the model in the same function. In the same function, you can see we are giving the technical details. That is which model you have to do the structural equation model, what data you will take, what kind of estimator you want, standardized values you want. So the Lavan syntax, which is very useful for giving the technical details for your model. The same specification given characteristics of our data, because we considered a 7-point scale for which measured variables as continuous because we found violations of the multivariate normality assumption required for same. We use the Lavan element estimator for our fitting function. If there is no such multivariate normality, then we will use this MLM estimator. So in this process, we have estimated our model. So these are the calculations behind the stage. and I would like to again go for the simple syntax and the simple libraries we need to do the structural equation modeling. Library Lavan plot for plotting the variance covariance structure, library DPLYR for simplify the data, tidyr for that purpose, library NITR, library MV normal test for multivariate normality checking. So I am just now stop the sharing. Is there any question?
Ma'am, there was one question from someone at the beginning of your session. So he was asking that why two factors? This is not clear. So I request to ask the question again to her so that she will answer your question properly.
And I would like to say some people have tried to join and they are giving me phone calls and also WhatsApp messages. They were
Yeah,
not able.
I have accepted all the participants who have in the lobby. So there is no one left in the lobby actually.
Okay, okay.
Yes, Aberdun, you can unmute yourself and ask the question what you want.
Yes, so thank you very much. So the question I wanted to ask. So the question I wanted to ask is about the two factor. Why the two factors? Is it because of the two sections, innovation and optimism? And can you use more than two factors? It was not really clear at the beginning.
Oh, this is a particular example. I have done a particular research on technology readiness index. There we have 4 factors, but for simplicity for this particular presentation, I have taken only 2 factors. So you can extend, I have shown you just 3 factors. You can have 4 factors. Whatever factors you have, you can just put it in your model and just make the list longer. It is not necessary you have to take only 2 factors. In this particular example, I have taken only 2 factors.
Okay, this is clear. Thank you.
Okay, thank you.
Okay, any other question from anyone else?
I also wanted to ask, is this only available on YouTube or is there any form of repository, maybe the analysis and the part in GitHub or any that we can still interact with the information further, or you just have to watch the YouTube channel just to.
Yes, you can contact me. You can contact me as your, if you need in your research.
Yeah,
Okay.
we have shared her email address and contact
Yes, yes.
information, so you can directly contact with her.
Okay. Thank you very much.
Yeah, thank you. Okay, anyone else? Okay, I think there is no more questions. So I think we can wrap up now, as there is no question from anyone else. So thank you, Susmita ma'am, for your interactive and quite interesting session, structural equation modeling with us. We are very happy to have you with us. And hopefully we are conducting our next meetup session in the next month with another guest speaker. Till then, take care. Keep following us. Keep watching our past events on the YouTube channel and subscribe our channel and follow us on LinkedIn and other social media platforms and also Meetup group. So till then, take care. Good night. Goodbye.
Thank you. Thank you so much.
Yeah, thank you.
Bye.